becoming a programmer, it opened the world for me. I'm super excited about AI. The feeling of wonder, that's the reason why I started developing software.
Programming with an agent is really empowering. That's like an extension of myself.
If you make artificial intelligence available to everyone to use, you can essentially make the superpower available to everyone.
Wow, you could really feel the energy in those voices,
Right.
right? That sense of excitement about building things, especially with AI.
Absolutely. Welcome to the deep dive. Today, we're jumping into a whole stack of material from a recent major tech conference, mainly a big keynote and some really interesting demos.
And it all points towards, well, a pretty fundamental shift that's happening right now in technology.
What shift is that?
It's this move towards what they're calling the open agentic web.
Open Agentic Web. Okay, sounds important.
It is. And our mission today is really to guide you through all this material. We want to cut through the buzzwords and help you understand what this agentic web actually is.
And why should you care? What does it mean for developers, or really for anyone?
Exactly. We'll look at the tools being built to make it happen. Think of this as, your shortcut to understanding this next phase of computing and the opportunities it opens up.
Okay, so where do we start? Satya Nadella, Microsoft CEO, he kind of set the scene, didn't he?
He did. He framed this moment, right now in 2025, as being in the middle innings of a really significant platform shift.
Middle innings, like not the beginning, but definitely not the end.
Right. And he put it into historical context, comparing it to other huge shifts we've seen. Think back to Win32 back in 91, or the web stack emerging around 96, or maybe more recently, the cloud and mobile explosion from about 2008 onwards.
So it's potentially that big of a deal.
That's the implication. He talked about moving away from a time where you had maybe fewer big apps, each with its own kind of deep, isolated technology stack.
Silos, basically.
Yeah, silos. And shifting towards a true platform model, one designed specifically to enable this open, scalable, agentic web.
And the goal behind that platform.
He was really clear on this. The core purpose is about expanding opportunity for you, the developer, right across every single layer of the tech stack.
Okay, expanding opportunity. Let's dig into that. Starting at the foundation seems logical, the tools developers actually use every day.
Right. And the scale here is already pretty mind-blowing. You've got Visual Studio with, over 50 million users?
50 million, yeah. And GitHub hit 150 million users.
And then there's GitHub Copilot. Already over 15 million developers have used it. That's incredible adoption.
It really is. So are these tools just getting faster releases and minor tweaks?
Well, there are those kinds of updates for sure. They mentioned improvements for Visual Studio Better.net and C++ support, live preview features, improved Git tooling, cross-platform debugging, even faster monthly stable releases.
And VS Code hitting its 100th release, that's quite a milestone. Things like multi-window support.
Exactly.
Yeah.
But the core insight, the big story from the sources, isn't just about those incremental improvements. It's that these fundamental tools are being completely reshaped by artificial intelligence.
AI is becoming central to how we code.
Precisely. And maybe the biggest signal of that was the announcement that they're actually open sourcing the Copilot integration within VS Code itself.
Wait, open sourcing Copilot?
Well, the integration part within VS Code. So bringing those AI capabilities right into the core of that incredibly popular open source editor, that's a huge move.
Okay, yeah, that makes sense. It really cements AI's place in the coding workflow.
Think about how Copilot itself has evolved, right?
Yeah.
It started out mostly suggesting code completions, helping you type faster.
Like autocomplete on steroids.
Kind of, yeah. Then it added chat, so you could actually ask it questions about your code, get explanations.
Then it moved to understanding context across multiple files, right? Multi-file edits.
Right. And now, the really significant leap they're talking about is Copilot evolving into agents.
Agents. Okay, there's that word again. This seems to be the heart of this whole agentic web idea.
It really is. And it's a shift in thinking. Forget just asking an AI a question or getting a suggestion. An agent is, it's an AI entity that you can actually delegate tasks to.
Delegate tasks. How does that work?
The idea is the agent can understand the goal of the task, figure out a plan to achieve it, and then actually take action to execute that plan.
So it's not just passive help anymore.
Exactly. You can still ask questions, sure, or you can work side by side with it. But now you can also assign it work to do autonomously. It's about mixing and matching these different modes of interaction.
Okay, so what kinds of tasks are we talking about? Simple stuff.
Increasingly complex stuff, actually. That's what was fascinating in the sources. They detail some really powerful new agent capabilities.
Like what? Give me an example.
Okay, so there's an agent mode specifically designed for app modernization. Let's say you have an old Java 8 application. You can tell this agent, upgrade this to Java 21.
Whoa,
Yeah.
seriously?
Or migrate an on-premises application to the cloud. The agent can analyze the code, create a migration plan, suggest the code fixes needed.
And presumably learn from your feedback as you collaborate.
Exactly. Or, get this, an autonomous site reliability engineering agent, an SRE agent.
Okay, for handling live site issues.
Right. But instead of just sending you an alert saying, hey, there's a memory leak,
Mm.
this agent can actually jump in automatically. It can start triaging the issue, figuring out the root cause, and even begin taking steps to mitigate the problem.
So it's actually fixing things.
Potentially, yeah. And it doesn't stop there. It then logs the whole incident, fully documented, as a GitHub issue. It identifies the repair items needed.
Yeah.
And it can even assign those follow-up repair tasks back to, say, a coding agent to implement the permanent fix.
Wow, that connects the dots in a pretty powerful way.
This is where that idea of delegation really clicks.
Yeah.
They're introducing a full coding agent built right into GitHub itself.
Inside GitHub.
Yeah. And this is the transition they talk about.
Hmm?
Copilot moving from being a pair programmer,
The one sitting next to you suggesting code.
right, to being a peer programmer. A virtual teammate you can actually assign work to.
A peer programmer. Okay, that feels fundamentally different.
It is. You can assign it a specific GitHub issue, maybe fixing a known bug, maybe implementing a brand new feature someone requested, and this agent can work on that task autonomously.
Autonomously. And is this, like, coming soon or...
The key announcement at the conference was that this capability is available now to all developers.
Rules of Velvet. Okay, just take a second. You, the listener, think about that. What routine bug fixes, what boilerplate feature implementations, what tedious coding tasks could you just hand off to a reliable virtual teammate?
Satya Nadella even shared a funny anecdote. He said, with these new capabilities, he's actually finding himself being assigned bugs to fix by Copilot now.
Ah. Okay, that definitely illustrates the shift in roles. So how does this actually work in practice? Did they show it?
They did. They demoed a workflow. Imagine you assign a GitHub issue to the Copilot agent. Let's say the task is add a product filter with caching to the web app.
Okay, pretty standard feature request.
Right. The Copilot agent picks up that issue. It understands the goal, and it starts working. It creates a draft pull request.
A PR. Okay,
Sets up
cool.
its own development branch separate from your main code.
Yeah.
It uses GitHub actions behind the scenes to get the compute power it needs.
And it writes the code.
It writes the code, commits its work to session logs. And here's a key part. It respects enterprise security measures. It works within its own defined environment.
How does it interact with things like the repo?
It uses something called the Model Context Protocol, or MCP. Think of MCP as like a standard language or a secure handshake. It lets the agent safely interact with external systems or context.
Context like the GitHub repository itself, or maybe even your local file system.
Exactly. It lets the agent get the information it needs, like the current code, the issue details, and understand what actions it's actually allowed to take within that context securely.
And because it creates a draft PR, a human still needs to look at it, right?
Absolutely. Human review, code reviews, all the standard checks still happen before anything gets merged into the main code base. This isn't about replacing developers.
It's about augmenting them, handling some of the workload.
Precisely. Augmenting capabilities, changing the workflow, and they were clear they want to build an open ecosystem around this. They want partners in the community to build all sorts of specialized agents, SRE agents, different kinds of software engineering agents, code review agents, you name it.
So this idea of an agentic coding experience, it's not totally brand new, but it feels like it's hitting a new level of maturity now.
Definitely. Sam Altman from OpenAI actually joined the keynote to share his perspective. He noted they've actually been talking about this vision, this agentic experience, since way back with the first version of Codex in 2021.
So it's been a long-term goal. And what's his take on where we are now?
He called this moment one of the biggest changes to programming that I've ever seen. Pretty strong words.
Yeah, no kidding.
He really leaned into that idea of having a real virtual teammate that you can genuinely delegate work to.
And the practical benefit of that.
He stressed the power. It unlocks the ability to issue many requests in parallel. Imagine telling your agent team, fix these 5 bugs across these different projects, implement these 2 small features, and answer this question about the database schema. All happening simultaneously.
Okay, that's beyond pair programming. That's
It's called a true software engineering task delegation.
right. Did he give any hints about where the AI models themselves are heading?
He did. He gave some interesting insights.
Mm.
He believes the models will obviously keep getting smarter,
Yeah.
but also, crucially, simpler to use. They'll get better at automatically doing the right thing without complex prompting.
More intuitive.
Yeah, and much more reliable. So you
Okay.
can genuinely trust them for much, much more. Plus, they'll gain more features, better multimodality, understanding images, video, etc., deeper integration with external tools, moving closer and closer to that point where it just works.
Sounds good. What about advice for developers trying to navigate all this change? It feels pretty fast-paced.
He acknowledged that. He said the rate of change AI is bringing is difficult for anyone to manage. But his strong advice was to lean into the new tools and the sort of new workflows that are possible.
Don't fight it. Embrace it.
Pretty much.
Yeah.
He framed technological shifts like this as being quite rare historically. And he believes that leaning in early, adopting these new ways of working is usually very rewarded.
Rewarded how? Productivity.
Productivity, competitive advantage. He shared an observation from within OpenAI. He said that the people who are early adopters of tools like Codex, they changed their development workflow very quickly.
Right.
And as a result, they were able to achieve an incredible amount relative to someone else.
That really paints a picture. It suggests these agentic workflows could offer significant gains for those who adopt them.
Definitely. Now let's shift gears a bit and move sort of up the stack from pure developer tools to the broader world of work, specifically Microsoft 365.
Okay, Office, Teams, that whole suite. How do agents fit in there?
Well, this was framed as another huge platform opportunity for agents. The big news was that Microsoft 365 Copilot is now generally available.
Generally available, meaning out of preview, ready for widespread use.
Exactly. And Satya Nadella described this GA release as the biggest update to Microsoft 365 since Teams itself was launched. That's a strong statement.
So what is M365 Copilot, fundamentally?
He framed it as the UI for AI within your work context. It's designed to bring together several core AI-powered capabilities into one intuitive experience.
Like what?
Things like chat, search, the agents themselves, something called notebooks, and create capabilities. It's basically about putting AI to work across all those everyday tasks you do in M365.
Okay, let's break those down. Chat seems obvious, but how is it different?
This was highlighted as the real game changer. M365 Copilot's chat isn't just based on general web knowledge. Critically, it's grounded in your work data.
My emails, my documents, my meeting transcripts, my files.
Exactly. It understands the context of your specific work, which makes its answers and assistance much more relevant and useful.
That makes sense. What about search?
Search is expanding beyond just finding your M365 documents. It's designed to work across all the applications you use, pulling information from Confluence, Google Drive, JRA, ServiceNow, wherever your work information lives.
Okay, breaking down those data silos again. And notebooks.
Notebooks sound interesting. They let you gather what they call heterogeneous collections of data. So pulling together relevant chats, documents, web pages, emails related to a project.
All in one place.
Yeah. And then you can do things like generate summaries or even get audio reviews or podcasts out of it. And Create is more about generating new content, turning a presentation outline into a full slide deck, or generating images based on a description.
So within this M365 Copilot experience, are there different kinds of agents?
Yes, they highlighted some specialized agents. There's a researcher agent designed to synthesize information from both the web and your internal enterprise sources. It applies deeper reasoning, like a chain of thought, to give you comprehensive answers, complete with citations back to the source documents.
So you can trust where the information came from.
Right. And there's an analyst agent. This one can take raw data, maybe from Excel files or other sources, derive insights, run forecasts, and generate charts and visualizations.
It feels like the goal here is moving beyond just information at your fingertips to putting actual expertise at your fingertips.
That's a great way to put it. And the integration with Microsoft Teams is key to making these agents collaborative.
How so?
Agents that you build or ones that you get from partners can actually appear right inside Teams and inside the main Copilot interface.
So I can interact with them in my chats or meetings?
Exactly. You can ask an agent questions during a meeting, assign it action items, or even kick off a complex workflow just by mentioning the agent's name in a chat conversation.
That sounds pretty seamless.
They mentioned a specific Teams AI library designed to make building these kinds of multiplayer agents easier for developers. It has built-in support for that MCP protocol we talked about, and also for giving agents memory so they can remember context across interactions.
Okay, so if I'm a developer and I build a really useful agent for, say, project management, How do I get it out to users?
That's where the new agent store comes in. It's basically a marketplace. Developers can publish their agents there.
And users across M365 and Teams can discover and install them.
Exactly. Potentially reaching hundreds of millions of users.
We saw some examples of this already happening, right? Partners connecting their services.
Yeah, good examples. A Workday agent that can summarize your pending HR tasks right in Copilot. A ServiceNow agent giving you real-time IT incident information, or even generating a PowerPoint report about an outage. Or an LSEG agent helping financial professionals analyze market data directly within Excel or PowerPoint.
So it connects Copilot to these essential business systems.
Precisely. But what if you need something really specific to your own company's unique processes?
Can you build your own?
Yes, that's the role of Copilot Studio.
Oh.
It's the tool set for building your own custom agents. You can mix the power of large language models with more traditional deterministic workflows if needed.
Okay, so you're not limited to just pure AI responses.
Right. And a significant new capability they announced for Copilot Studio is multi-agent orchestration.
Orchestration, like agents working together.
Exactly. It lets you design more complex workflows where several different agents collaborate to complete a process.
What's an example of that?
The one they used was new hire onboarding. A notoriously complex process, right? Involving multiple departments.
Facilities, IT, HR, finance, legal.
Yeah. So you could orchestrate this.
Yeah.
Maybe the main onboarding agent triggers a separate agent managed by facilities to arrange the desks setup, another agent from finance to handle payroll setup, one from legal for document signing. Bring them all together to automate and really speed up the whole thing.
That makes a lot of sense for those cross-functional processes. They mentioned huge uptake already, right? Something like 1 million agents.
Yeah, they noted over 1 million agents have been connected with Copilot and Teams in just the past year. Shows how quickly people are exploring this.
Okay, but building agents is one thing. What about making the core Copilot experience itself smarter about my specific company?
That's where perhaps one of the really big deal announcements comes in. Copilot tuning.
Tuning, like fine-tuning an AI model.
Exactly. This moves beyond just using Copilot as it comes out of the box. It's about tailoring Copilot, tuning it specifically for your customer base, your enterprise, maybe even your individual firm or department.
Tailoring it how?
Imagine tuning Copilot so it deeply understands and consistently uses your company's unique tone of voice, your specific terminology, your industry jargon.
So it sounds like it belongs here.
Right. And soon, they said, it will be able to learn your specific expertise, your proprietary knowledge, the nuances of your business that aren't public information.
Okay, how does that tuning process work? Is it complex?
They described it as being pretty straightforward, actually. You've basically seed a training environment with a relatively small set of representative documents, examples of your company's writing style, or documents reflecting that specific knowledge.
Just examples, not massive data sets.
Seems like just good examples are needed. Then you kick off a training run. The result is a customized version of the Copilot model.
And security, if it knows my internal stuff.
Crucially, that resulting custom model automatically inherits your existing security permissions. It can only be deployed and accessed by users who are already authorized to see that underlying information.
That's critical for enterprise use. What could you do with this?
The possibilities are pretty powerful. Think of a law firm. They could tune Copilot on their massive library of past arguments, case law analyses, internal memos.
So it could help draft new arguments or answer legal questions reflecting the firm's specific precedents and style?
Precisely. Or a consulting company. They could tune different models for each vertical industry they specialize in, embedding their unique frameworks and know-how right into the AI. It's about amplifying the collective intelligence and expertise of the firm itself.
Okay, this is getting really interesting. Let's try and make it more concrete. There were some demos, right? Midi Joshi showed some of this in action.
Yes. She had a great set of demos connecting these pieces. First, she showcased the main M365 Copilot app, reinforcing that idea of it being a 5-in-1 hub for your AI-powered work.
And she showed one of the specialized agents.
She did. She demonstrated the researcher agent. She asked it to analyze performance issues by reasoning over a GitHub project backlog.
So using real work data.
Exactly. And what was really neat was seeing it ask clarifying questions back to her and then showing its chain of thought how it arrived at its conclusions. And critically, it grounded its analysis in both web data and the specific work data from GitHub, providing citations back to the sources.
Transparency is key there. Did she show how developers actually get that kind of organizational data into Copilot?
Yes, that was a good part. She showed building a connector in Visual Studio. Using the M365 Agents Toolkit, you get scaffolded code with just a few clicks.
Scaffolding helps speed things up.
Definitely. Then you modify that code using Microsoft Graph APIs. That's the gateway to M365 data. You define a schema for the data you want to bring in, maybe use the GitHub API in this case to fetch the actual issued data, and then you ingest that structured data into Microsoft Graph.
So Copilot can then reason over it.
Exactly. She even showed the indexing log, so you could see the process of that data being made available to the AI.
Okay, shifting to Copilot Studio, building those custom agents, what did she show there?
She had built an RFP response agent request for proposal. She showed it running inside Microsoft Teams.
A common but time-consuming business task.
Right. And the agent generated a really professional-looking proposal document that accurately reflected the company's specific content, their preferred language and tone, and even their standard formatting.
And she walked through how she built it in the Studio UI.
She did, showing how you define the agent's overall goal, provide specific instructions, choose which underlying AI model to use GPT-4o as the default, but you could select others, including models from Azure AI Foundry, which we'll get to.
And grounding it is important, right? Making sure it uses the right info.
Crucial. She showed selecting specific knowledge sources, SharePoint sites, documents to ensure the agent was pulling information only from the correct, approved, internal organizational sources.
Can these agents react to events?
Yes. She showed adding triggers. For instance, configuring the RFP agent to automatically start its process whenever a new email flagged as an RFP arrived in a specific inbox.
And connecting to other systems, like for pricing data.
Yeah, linking the agent to those MCP servers we talked about. She showed connecting it to Dynamics 365 to pull real-time SKU and pricing data, ensuring the proposal was always accurate. Also connecting to third-party services like DocuSign for signatures, or even custom-built servers to fetch data from internal systems like SAP for customer account details.
Okay, so agents can pull data from lots of places. What about that multi-agent orchestration idea? Did she demo that?
She did, yeah. She showed linking her RFP agent to a separate agent responsible for compliance reviews.
Ah, so the RFP agent creates the draft.
Then it initiates a connection to the compliance agent. The compliance agent does its checks. If it passes, control returns to the RFP agent, which can then proceed with the next step, like sending it for approval. It showed how these specialized agents can cooperate on a more complex, multi-step workflow.
That's powerful. And finally, Copilot tuning, making Copilot smarter about specific tasks.
Right. She demonstrated tuning a model specifically for contract writing, showing how it could be done with a low-code interface.
And the result.
She showed a contract builder agent she created, running inside the main M365 Copilot app. She asked it to draft a contract based on some example documents she provided.
And because it used the tuned model.
Exactly. The draft contract it produced via email accurately reflected the company's specific legal language, standard terms, preferred structure, even the formatting, all learned from the tuning process using their contract database.
How easy was it to create that tuned model in the demo?
It looks surprisingly simple. In the interface, you create a new model, give it a name and description, specify the task type, like contract writing. Then you add the knowledge source, in this case, a SharePoint library containing their existing contracts.
And specifying who can use it?
Yes, crucially, specifying which teams should have access, like the contracts team and procurement team. Copilot ensures that access aligns with existing permissions. Then, some experts might label a small amount of data to guide the tuning. You complete the training and publish the model.
And then that tuned model just shows up as an option when building agents.
Exactly. She showed creating a new task-specific agent in the M365 app and simply selecting her newly tuned contract builder model as the engine for it.
Okay, pulling back from the demos, what's the big picture here?
I think there are two key takeaways. First, this is all about enabling scaled developer work. Providing these higher-level building blocks, these studios and tuning capabilities, lets developers create much more sophisticated AI-powered solutions faster.
And the second takeaway?
It's about empowering business users, the people who actually live these workflows every day. Giving them tools like Copilot Studio, even the low-code tuning, allows them to directly reimagine and automate their own processes using AI without necessarily needing deep coding expertise themselves.
Democratizing AI application, in a sense.
You could say that. Now, all of these agents, whether in GitHub, M365, or custom build, they need a robust platform underneath them to run effectively.
Which brings us to Azure AI Foundry.
Exactly. Foundry was positioned as the complete app platform for the AI age. Think of it less as just a place to run models and more as a production line for intelligence.
A production line,
meaning it provides the entire system around the AI models themselves, all the crucial tooling for things like model evaluation, orchestration of complex agent workflows, and sophisticated retrieval augmented generation, that R process we talked about, for grounding models in real data.
Got it. It's the factory floor for building and running these AI applications. Is it being used much yet?
At significant scale, apparently. They mentioned over 70,000 organizations are already using Foundry, and it's processed over 100 trillion tokens in just the past 3 months.
100 trillion, that's a lot.
It's a 5-fold increase year over year, so adoption is clearly accelerating rapidly.
Any cool examples of what people are building with it?
Satya shared a really inspiring one from Aizen in Japan. They used Foundry to build an application specifically designed to help people who have auditory processing disorder better understand what they hear in conversations.
Wow, that's a fantastic application of the tech.
He said seeing videos like that demonstrating that kind of real-world human impact is when he knows things are becoming real. It's not just abstract technology anymore.
Right, so within Foundry, what about the AI models themselves? Choice seems important.
Absolutely. And choice is a core strength here. Foundry provides access to, get this, over 1,900 different models.
1,900. What kind of models?
All sorts. General response models like GPT, specialized reasoning models, models built for specific tasks, multimodal models, a huge catalog.
And the partnership with OpenAI seems key.
Very key. They highlighted that 15 new OpenAI models have been sim-shipped on Azure this year.
Sim-shipped, meaning available on Azure the same day OpenAI releases them.
Exactly. Zero delay. And the big news on that front, Sora, OpenAI's really impressive text-to-video model, is coming to Azure literally next week.
Sora on Azure. Okay, that will be interesting to see. And Azure OpenAI offers more than just access, right? Enterprise features.
Yes. They stress the benefits like best-in-class cost efficiency, high reliability, low latency, top-quality output, plus all the crucial enterprise guarantees around security, compliance, data privacy, and responsible AI safeguards. Things like cost controls via batch processing or spillover.
Using multiple models can get complex, though. How do you choose the right one?
Good question. To help with that, they introduced a new model router service within Foundry. The idea is it can automatically select the best OpenAI model for a specific task you give it based on the task's characteristics and the model's strengths, simplifying that multi-model usage.
Okay, that's helpful. Any other major model news?
Big one. Grok from Elon Musk's xAI is coming to Azure AI Foundry.
Grok on Azure. Interesting. What's the pitch for Grok?
Grok 3 was described as combining strong reasoning capabilities, deep search integration for real-time information, and powerful response generation all within a single model.
And Elon Musk himself showed up to talk about it.
He did, yeah. In a chat segment, he actually reminisced a bit about his own early programming days back with DOS and Windows 3.1. Said he's still a PC gamer.
Okay. What's his vision for Grok, specifically Grok 3.5?
He emphasized its focus on trying to reason from first principles, applying the tools of physics to thinking, as he put it, boiling problems down to their most basic axiomatic elements before building up a solution.
And a different approach to reasoning.
Seems so. He also stressed the goal of aiming for truth with minimal error, stating that for AI safety, honesty is the best policy, is a core principle for Grok.
And did he mention the developer community?
Yes, specifically. He made a point of saying they're actively seeking feedback from developers to help make Grok better and ensure it really serves their needs as they integrate it into applications via Foundry.
So Foundry offers OpenAI models, Grok. What else? A wide open ecosystem?
Very much so.
Yeah.
They mentioned lots of other models available or coming soon. Mistral, for example, with important options for sovereign deployment within specific EU regions, crucial for companies needing data residency guarantees.
The full Llama family from Meta.
The full herd is coming, representing the latest advances in powerful open source models, plus models from places like Black Forest Labs, and access to over 11,000 models via the Hugging Face integration. It's a massive selection.
Managing capacity across all those different models sounds challenging, though.
This was highlighted as a potential game changer. Foundry allows you to provision a certain amount of compute throughput capacity once.
Okay.
And then you can flexibly use that same provision capacity across many different models, including Grok, Mistral, Llama, OpenAI models, etc.
So I don't need separate dedicated infrastructure for each model type.
Exactly. It makes experimenting with and deploying diverse models much more efficient and cost-effective. Plus, many of these models now share the same API signature, making switching between them much easier from a code perspective.
Okay, that is a big deal for flexibility. But we established models aren't enough on their own, right? Agents need knowledge.
Precisely. Raw model intelligence isn't sufficient. Agents need access to real-time, relevant knowledge both from the public web and, critically, from within the enterprise's own data stores.
This is where that RAG technique comes in again, retrieval augmented generation.
Yes. But the sources emphasize that for truly effective agents dealing with complex tasks, we need more sophisticated retrieval systems than just basic vector search or keyword matching on embeddings.
What's needed then?
They described it as needing a true knowledge engine, a query engine custom built for agents, something that can take a complex, multifaceted query from an agent.
Like, find recent customer feedback related to feature X, compare it to sales trends for that feature in the last quarter, and summarize the key concerns mentioned in support tickets.
Exactly that kind of complex query. The engine needs to be able to break that down into subqueries, run those parts in parallel against different data sources, web, documents, databases, and then intelligently synthesize the results back into a coherent answer for the agent. Think of it as a modern knowledge retrieval stack.
Okay, so Foundry provides the models and this advanced retrieval. What connects them? The orchestration.
Right. That's the role of the Foundry Agent Service. It's the orchestration layer. It lets you build those declarative agents, defining what you want the agent to do, rather than coding every step, often with just a few lines of code.
And it supports agents working together.
Yes, it supports that complex multi-agent orchestration we discussed. It also integrates nicely with popular agent development frameworks that people might already be using, like Semantic Kernel or Autogen. It's essentially a managed service providing the execution environment for these agents.
Is this agent service widely used?
It's now generally available, and they mentioned it's already being used by over 10,000 organizations. So significant uptake there, too.
Okay, models, retrieval, orchestration. Where does all this actually run? The compute layer.
Good question. Azure provides a whole spectrum of options here, recognizing that different tasks have different needs. You can go fully serverless with Azure Functions for event-driven tasks.
Low overhead pay-per-use.
Right. Or use Azure Container Apps for more control over the environment, but still with serverless scaling benefits. Or for maximum control and customization, you can deploy into Azure Kubernetes Service, AKS. It's all about letting you optimize for that balance between price and performance.
And Foundry connects easily to these.
Yes, they highlighted how straightforward it is to connect your Foundry setup to your chosen compute environment, whether it's container apps or functions. You can even take open source models from Foundry and deploy them into your AKS clusters.
Does that work for hybrid scenarios too, like on-prem servers?
Yes, using Azure Arc, you can manage and deploy these containerized models and agents consistently across both the cloud and your own hybrid infrastructure, even right out to edge locations.
And you mentioned closing the loop between Foundry and Copilot Studio earlier.
Right, this is powerful. You can take an AI model that you've maybe fine-tuned or post-trained within Foundry, perhaps on your company's unique data, to give it specialized knowledge, and then you can seamlessly bring that custom model into Copilot Studio.
And use it there to build a custom agent or automate a workflow.
Exactly. Using your specialized Foundry-trained model right inside the M365 Copilot or Teams experience via Copilot Studio.
That connects a lot of dots. We saw an example of this kind of complex orchestration in action, didn't we? The Stanford Medicine one.
Yes, that was a really compelling example of bringing multiple agents together for a truly mission-critical task. Improving cancer care tumor board meetings.
Tumor boards involve doctors from different specialties reviewing complex cases, right? Lots of data involved.
Extremely data-intensive and often fragmented. Stanford used Azure AI Foundry to orchestrate multiple agents working together.
What did these agents do?
They pulled together all that disparate information needed for a case review. The patient's history, radiology reports, lab results, pathology findings, relevant medical literature from PubMed, even data from ongoing clinical trials. The goal was using AI orchestration to synthesize this fragmented data into a coherent picture for the clinicians.
Making those meetings more efficient and effective.
Exactly. Faster, potentially more accurate decisions. They used RAG techniques, grounding the AI summaries and insights directly in the patient's clinical notes, ensuring it was relevant and trustworthy.
And how is this delivered to the doctors?
The output was integrated directly into the tools they already use, like summaries in Microsoft Word or slides in PowerPoint. And crucially, they deployed this complex agent orchestrator directly into Microsoft Teams with just a few lines of code, making it easily accessible within the clinical team's existing workflow.
That integration is key for adoption.
Absolutely. And Stanford emphasized they're delivering this not just as a one-off solution, but as a platform that they can share with other community hospitals, helping to scale the impact of this AI-driven approach. And the great news? This healthcare agent orchestrator is now available as a template for everyone within Foundry.
That's fantastic. Democratizing that kind of advanced capability. What about managing these AI systems once they're running?
Good point.
Yeah.
They also discuss the importance of observability for AI in production. Foundry is getting new features specifically designed to help you monitor and manage the real-world impact, the quality, the safety, and crucially, the cost of your running AI applications and agents.
Because these things can consume resources quickly if not managed.
They can. And thinking about a future where humans and AI agents are collaborating closely, existing enterprise systems need to adapt. Things like identity management, access control, security. They can't just be for people anymore.
Agents need identities too.
Exactly. That's where Entra ID for agents comes in. It gives each agent its own secure managed identity within your organization's directory.
So you can assign permissions to an agent, apply security policies, control what it can access.
Precisely. Just like you would for a human employee. Agents built in Foundry and Copilot Studio can automatically show up in a dedicated agent directory within Entra ID. They're also working with partners like ServiceNow and Workday so that agents provisioned within those systems can also get managed identities via Entra.
What about protecting the data the agents use?
Microsoft Purview integrates with Foundry to provide data governance and end-to-end data protection, ensuring that agents handle sensitive information according to your policies.
And protecting the agents themselves from attack.
Microsoft Defender integrates with Foundry too, extending security protection to the agents themselves, treating them like any other endpoint that needs protection against threats like credential theft or, interestingly, wallet abuse, perhaps preventing agents from making unauthorized transactions or consuming excessive resources.
Okay, that covers the security and management angle. To really see how developers interact with all this, we had those great demos from Kadesha Kerr and Divya Venakataramu, right?
Yes, they really brought the developer experience to life, showing how Azure AI Foundry and GitHub Copilot, especially with the new agent mode, can make things easier.
Kadesha started with that AI travel agent app, Vibe Travel.
Right. She showed a common problem. The AI giving a bad suggestion, suggesting skiing in New Zealand in the middle of their summer. A grounding issue.
How did she fix it?
Remarkably easily, within the Foundry Agent Settings UI, she simply added Bing Search as an additional grounding source for the agent. Just a checkbox, basically. And boom, the corrected response was accurate.
Simple fix. And she moved beyond just Q&A.
Yes, she showed adding actions to the agent, moving it from just answering travel questions to actually doing things like booking a flight for the user, adding the booking to their calendar, maybe even requesting hotel options or submitting a leave request via an internal system, turning it into an autonomous agent.
Then she switched to the developer workflow, using GitHub Copilot's new agent mode.
Exactly, right inside VS Code. She showed how Copilot, acting as that peer programmer, could interact with her GitHub repository using the GitHub MCP server.
MCP, again, the Secure Connection Protocol.
Right. It allowed Copilot to understand the context of her repo, the issues, the code. She asked it to check the issues assigned to her.
And she demonstrated fixing one.
Yes. Issue #1 was about adding a warning confirmation modal before a user clicked a reset button. She asked Copilot Agent Mode to implement it.
And this involved that Figma design?
Yes. This was cool. Her manager had provided a design sketch in Figma. Copilot, using its new vision capabilities, enabled via the GitHub MCP server after she granted permission, could actually look at that Figma sketch. She called it a pretty sweet design.
So the AI understands the visual design now.
It seems so. Copilot examined the existing code base, found the relevant files, and then wrote the code to implement the UI modal, making sure it adhered to the project's existing style guides and coding standards. She showed the resulting modal working in the application.
That's impressive integration. What about the delegation aspect, checking on work assigned to Copilot?
Right. She checked on that issue Satya had supposedly assigned to Copilot earlier, adding a group size filter to the travel app.
And had Copilot done it?
It had. She showed that Copilot had already opened a pull request. The PR description included details of the changes, adding the necessary filter property, implementing Redis caching logic for performance, even providing instructions on how to test the feature.
And it deployed it.
Copilot had deployed its changes to a staging environment. Kadesha was able to pull up the live staging website and show the new group size filter working correctly, all done autonomously by the agent. The demo really showed how you could make significant progress on multiple fronts, fixing one issue yourself with AI help while delegating another entirely.
Okay, Kanesh's demo focused a lot on Foundry and GitHub Copilot. Divya's demo took it a step further, right? Into Windows itself.
Yes, Divya's demo was fascinating. It showcased using Azure AI Foundry and GitHub Copilot with MCP integration running directly on Windows, all orchestrated from within VS Code.
MCP on Windows. How does that work?
She showed how Windows is being modernized for this Agentic Web. There's now native support for MCP built into the operating system. Users can manage permissions for different MCP servers directly in Windows settings.
Like deciding which applications or system components an agent running on your PC is allowed to talk to?
Exactly. She showed enabling the MCP server for WSL, Windows Subsystem for Linux, and for the Figma desktop app, while others might be disabled by default. It puts the user firmly in control.
Okay, so what did she do with this setup?
Using GitHub Copilot in agent mode, she gave it a surprisingly complex multi-step request in just 3 natural language sentences.
What was the request?
Essentially, find the latest version of Fedora Linux in WSL and install it for me. Once that's done, set up a simple Node.js website project inside that Fedora environment.
All from one prompt.
All from one prompt. Copilot first established a secure connection with the WSL MCP server on her machine, prompting her for consent first.
Security first.
All right. Then it queried the available online Linux distributions, found Fedora 42 was the latest, and proceeded to install it within WSL.
Wow.
On another machine, where this setup was already complete, she showed the result. Copilot had successfully parsed the whole multi-step request. It had set up Fedora, then used the DNS package manager inside the WSL environment to install Node.js and NPM. It knew how to interact with WSL directly on her device to run these commands. And she showed the basic website project structure it had created.
That's serious automation just from a few sentences. What was the third part of her request, the Figma part?
Right. She then said to Copilot, referencing the same Figma design Kadesha used, "Can you make my website look like the design I've selected in Figma? Pull the design details and apply them to my project." And she had the Figma desktop application open with that design selected.
So Copilot needs to talk to the Figma app running on her desktop.
Exactly. Copilot established another secure MCP connection, this time to the Figma MCP server, again after user consent. It queried the Windows MCP registry to discover the Figma server was available.
And then?
It pulled the design details, colors, fonts, layout information directly from the running Figma desktop application. It then integrated those details into the Node.js project's code, instantly updating the website's layout, design, styling, even content placeholders to match the Figma design. She showed the code changes and the resulting website, looking identical to the Figma mockup.
All driven from the chat interface in VS Code, interacting securely with WSL and a desktop app on her own PC via MCP. That's pretty amazing.
Really showcased the power of combining Copilot agent mode with MCP running natively on Windows. Secure agent-driven development, integrating seamlessly with local tools and environments.
And speaking of WSL, there was a nice little coda to that segment.
Yes. They announced that WSL, the Windows Subsystem for Linux, is now fully open source, which apparently closes out the very first issue request that was ever opened for WSL nearly 10 years ago. A nice moment for the community.
Definitely. Okay, so we've seen agents encoding in M365, built with Foundry, running on Windows. What's the bigger picture vision for this whole ecosystem? Kevin Scott, Microsoft CTO, offered some perspective on that, right?
He did. He zoomed out to talk about the broader vision for this open agentic web. He suggested it actually brings us closer, in spirit, to the original ethos of the World Wide Web, this idea of a decentralized network with intelligence and content distributed everywhere, not locked in central silos.
An interesting parallel. How did he define agent in this broader context?
Simply and effectively. A thing that a human being is able to delegate tasks to. But he emphasized that the complexity of tasks these agents can handle is increasing dramatically, thanks to the rapid improvements in the underlying AI reasoning models.
And this is happening fast.
He described it as an explosion of agents. Mentioned that daily active users of these kinds of agentic capabilities have more than doubled just in the past year. Agents are tackling extremely complicated tasks, he said, especially within software engineering, fueled by these new models.
What enables these agents beyond the models themselves? The runtime.
Exactly. He talked about the necessary runtime layer that sits above the agents. Components being built by Microsoft and, crucially, by the open community. While reasoning models are getting much better, he even mentioned a capability overhang suggesting the models can do more than we're currently asking them to.
A challenge to developers to be more ambitious.
Pretty much. But he also highlighted a key missing piece for truly robust agents: memory.
Agent memory. We need more than just arg or long context windows.
That was his point. He argued for the need for robust agentic memory, something more persistent, allowing for broad, high-precision recall over long periods. This is crucial for building trust, enabling true personalization, and making interactions feel less transactional, more like dealing with something that actually remembers you and your context. He mentioned Type Agent, an open-source project they released, as one potential approach to tackling this complex memory challenge.
And Foundry is the platform delivering these runtime components.
Yes, he positioned Foundry as the place where Microsoft is delivering these core runtime pieces, the reasoning, the emerging memory solutions, the orchestration, and he expects it to get richer and richer over time as new capabilities are added.
For agents to be useful, they need to do things, right? Take action.
Absolutely critical. He stressed they need to be plumbed up to the greater world, and that's where standard communication protocols become essential.
Like MCP.
Like MCP
Yeah.
and potentially A2A, agent-to-agent communication protocols. He reiterated Microsoft's strong commitment to MCP, saying it's taken off like crazy because it fills a really important niche in this open agentic web ecosystem.
Why MCP? What makes it suitable?
It's simplicity, mainly. He compared it to HTTP. It's a straightforward protocol, doesn't impose much opinion on the actual data payload being sent, which makes it really good for layering different kinds of capabilities and services on top.
So Microsoft is standardizing on it internally.
Yes, they're uplifting their own first-party services to use MCP, and they're partnering with others, like Anthropic, to tackle tough enterprise problems around agent identity and entitlements infrastructure, using MCP as a foundation. But the emphasis was on supporting the open community. Ubiquity is critical here. We need something standard that we can all use and build on top of.
Okay, so MCP connects agents to existing systems. What about making websites and APIs themselves more agentic?
This led to another interesting announcement. NLWeb.
NLWeb, what's that?
He described it, perhaps a bit playfully, as HTML for the Agentic Web. The core idea is to provide a simple way for any developer to make their existing website or API into an agentic application, easily exposing its capabilities and data in a way that LLMs and agents can naturally understand and interact with.
How does it work?
The key technical point is that every NLWeb endpoint automatically acts as an MCP server.
So anything built with NLWeb is instantly accessible and interactable for any agent that speaks MCP.
Exactly. It creates this inherent composability and layering, much like how the standard protocols of the internet allow the web to grow organically. He showed some early examples and prototypes built with partners like TripAdvisor and O'Reilly Media, and pointed people to a GitHub repository with an NLWeb UI demo. That demo showed taking web content, extracting structured data and metadata, computing embeddings, storing it locally, and then enabling really interesting, sophisticated queries that go way beyond simple database lookups.
It sounds like the overarching theme here is openness.
Yeah, absolutely. Kevin Scott really hammered this point home. The vision relies on simple, composable components being exposed to the creativity of every developer. He drew the parallel again. The web became amazing because of the collective imagination of millions of builders, not the vision of one single company. His closing thought was powerful. The sum total of your imagination operating on the agentic web is going to make the agentic web a fundamentally more interesting thing than anything one entity could create alone.
A call to action for developers everywhere. Okay, shifting down the stack again, let's talk about data. Obviously crucial for any AI app.
Super important, as they put it. They emphasize they're building out the full, integrated data stack needed for this AI era. They threw out some customer examples. Lumen, using Microsoft Fabric to save over 10,000 hours. Sitecore achieving a 10x performance speedup on their platform.
Any specific data-centric examples of AI in action?
Yeah, a really cool one was how the NFL Scouting Combine used the Microsoft Data Stack along with Azure AI Foundry.
The Combine, where they evaluate draft prospects.
Right. They used Azure OpenAI's GPT models, Cosmos DB for data storage, and Azure Container Apps for compute. The goal was to allow scouts and evaluators to instantly filter, search, and compare vast amounts of player statistics and evaluation notes.
Cutting through the noise.
Exactly. They said filtering data that previously would have taken hours of manual work could now be done in a matter of seconds, giving teams a real analytical edge.
Any big news on the core data products?
Yes, SQL Server 2025 is launching soon, And a key theme was bringing data and AI intelligence much closer together.
How so?
For example, integrating Cosmos DB, their globally distributed NoSQL database, directly into Azure AI Foundry.
Why is that useful?
Well, agents often need a place to store conversational history or state between interactions. Cosmos DB is great for that. It also provides a readily accessible source of data for RJ applications. They also announced deeper integration with Azure Databricks, connecting data there easily into Foundry, and even the ability to combine natural language prompts with traditional PostgreSQL queries in a single interaction with an LLM.
Mixing SQL and natural language.
Yeah.
Interesting. What about Microsoft Fabric, their unified analytics platform?
Fabric was positioned as the heart of their data and analytics strategy, bringing everything together. A key announcement there was bringing Cosmos DB into Fabric.
So unifying structured SQL data and semi-structured NoSQL data like Cosmos DB within the same platform.
Precisely. Making your entire data estate, regardless of type, unified and inherently ready for AI workloads.
Other Fabric updates.
A couple mentioned were a new digital twin builder for creating digital replicas of physical environments using a no-code, low-code approach, and something called shortcut transformations in OneLake, Fabric's data lake. This uses AI, powered by Foundry, to automatically apply common data transformation tasks during ETL, things like transcribing audio to text, running sentiment analysis, or summarizing long documents.
Automating data prep using AI makes sense.
Ugh.
And interacting with data using AI.
Yes, Copilot in Power BI was highlighted again. This lets users chat with their data in natural language, visually explore reports, and analyze semantic models without needing to be a Power BI expert. They called bringing reasoning models directly onto your structured Power BI data within a chat interface, a game changer for business intelligence.
Okay, data is covered. Let's go to the very bottom layer. The infrastructure that powers all of this AI, the silicon, the data centers.
Right, the engine. They framed this from the developer's perspective as a constant optimization challenge. How do you get the best possible performance and lowest latency while also managing costs effectively?
The eternal trade-off.
Their approach is what they called a systems-level optimization, looking at the entire stack as one integrated system, from the physical data center design and the custom silicon inside the servers to the system software, the network, and the application server, and optimizing it all together.
What's the goal metric for that optimization?
Simple and clear. Achieving the most tokens per watt per dollar, maximum AI output for the minimum energy consumed, and the lowest cost.
And this involves multiple factors improving at once.
Exactly. They talked about multiple S-curves of innovation compounding. You've got the classic Moore's Law improvements in silicon performance, plus ongoing optimization in system software, plus optimization within the AI models themselves to make them more efficient, all combining for significant performance gains. And a key focus for them is the speed at which they can deploy these new infrastructure capabilities across their massive global fleet.
Any specific hardware announcements?
A big one. Azure is the first cloud provider to bring NVIDIA's latest generation GB200 AI accelerator systems online at scale.
GB200, the successor to Hopper. That's cutting edge.
Very much so. And they claimed leading performance from a single GB200 rack configuration using NVLink interconnects, reporting speeds of 865,000 tokens per second. They cited this as the highest throughput currently available from any cloud provider for that configuration.
NVIDIA's CEO Jensen Huang joined the discussion too, right?
He did. He reiterated the
Yeah,
shared
too.
goal with Microsoft, constantly pushing to deliver more intelligence, more tokens per dollar per watt.
But what did he highlight about the partnership?
He reminded everyone they launched what was then the largest AI supercomputer together on Azure just 2 years prior. And he emphasized the incredible speedup achieved since then, claiming an insane 40x speedup over Hopper systems in just those 2 years.
40 times how?
He attributed it to the combination of innovations across the stack, improvements in NVIDIA's CUDA algorithms, advances in AI model technology itself, and the optimizations within the Azure AI infrastructure they run on. Joint innovation paying off.
Did he talk about compatibility? Ensuring developers' investments last?
Yes, that was an important point. He stressed the need for architecture compatibility across hardware generations. This provides ecosystem stability and allows developers and customers to amortize their significant investments in software and models built on that architecture, like CUDA.
Makes sense. What about utilizing these powerful systems efficiently? They're expensive.
Right. He talked about leveraging CUDA's massive existing install base and its general-purpose computing nature. While these systems excel at AI training and inference, The goal is to accelerate a wide diversity of workloads. Their teams work hard on accelerating data processing. He mentioned 20x, 50x speedups, video transcoding, image processing, scientific computing, alongside the AI models.
So keep the fleet busy doing useful work, not just AI.
Exactly. Fully utilize the fleet for its entire lifespan, accelerating all workloads per dollar per watt, as he put it.
Beyond the chips, what about Azure's overall infrastructure scale?
It continues to grow rapidly. Over 70 Azure data center regions now operational worldwide, with 10 of those having opened in just the last 3 months.
And the physical design of these AI data centers is changing.
Drastically. They discussed advanced cooling solutions, like the Maya Sidekick liquid cooling system, specifically designed for high-density hardware, like the GB200. It uses a closed-loop system requiring zero water consumption, which is significant for sustainability.
And networking. AI needs massive bandwidth.
Huge investments there. They claim to have laid more fiber optic cable in the last year than existed in all of Azure prior to that. This is building out what they call the AI WAN, a 400 terabit per second backbone network, connecting their data centers globally, essential for large-scale distributed AI training and inference.
Are they using their own custom chips too?
Yes, for compute efficiency and general workloads, they highlighted their Cobalt ARM-based VMs.
Yeah.
These are already powering large parts of Microsoft's own services like Teams and Defender, and they're enabling USP partners' customers using large-scale custom infrastructure solutions to scale effectively and efficiently on Azure's ARM architecture.
Okay, massive scale, cutting-edge hardware. Can we see an example of this infrastructure enabling something truly impactful?
Absolutely. The Met Office example from the UK was fantastic. They're the UK's National Weather Service.
And they're using Azure for weather forecasting.
Yes, they've built what they described as the most advanced supercomputer of any kind for weather and climate science on Azure.
A supercomputer for weather in the cloud.
Exactly. It's the world's first cloud-based weather forecasting supercomputer. They explained that numerical weather prediction requires absolutely massive storage and compute power. To increase the accuracy of forecasts, you need to run models at much higher resolution, and that demands this kind of supercomputing capability.
What does running it on Azure enable for them?
They highlighted Azure's ability to reliably deliver these massive-scale services. And crucially, integrating their scientific supercomputing directly into the broader Azure ecosystem allows them to develop new and currently impossible products and services by combining weather data with other Azure capabilities.
So better forecasts.
Significantly better. Running more complex models at higher resolution leads directly to more timely and more accurate predictions. They expect their customers, everyone from the public to aviation and energy sectors, will notice the improvements.
And the ultimate goal?
It's about building trust, ensuring people believe the forecasts, especially for severe weather events, and critically, that they act upon that information. It enhances everything the Met Office does, aiming ultimately to improve everyone's lives through better weather prediction and climate science. A really powerful use case for that massive infrastructure.
Definitely. They also touched briefly on security and control aspects of the infrastructure.
Yes, things like digital resilience, comprehensive compliance certifications, sovereign controls allowing customers in certain regions to maintain full data residency and operational control, and confidential computing capabilities to protect data even while it's being processed in the cloud.
And what about use cases that can't be in the main cloud?
Yeah.
Edge computing.
For those critical scenarios needing extremely low latency or the ability to run completely disconnected from the internet, they offer Azure Local, essentially bringing a slice of Azure infrastructure closer to or directly into the customer's location.
Okay, we've covered the entire stack, from infrastructure up to agents and applications, but then they took it one step further, applying this entire stack to a completely new domain.
Yes, science. This was the introduction of Microsoft Discovery.
Microsoft Discovery, what's the ambition here?
It's huge. The goal is to fundamentally accelerate the scientific discovery process itself, using AI and this whole platform to speed up the creation of entirely new materials, new chemical compounds, new molecules for medicines.
Wow, so like GitHub is for software development and M365 is for knowledge work.
Discovery is positioned as being for science, a dedicated platform to revolutionize R&D.
How does it work? What makes it different?
It's built on a really powerful knowledge engine that uses that graph RI technique we mentioned earlier.
Graph RI.
Right. Instead of just finding keywords in scientific papers, it builds a knowledge graph that understands the deep, nuanced relationships between concepts, experiments, and findings within a specific scientific domain. It reasons over this graph, pulling insights from both public literature and potentially a company's internal research data.
So deeper understanding than simple search.
Much deeper. And it's built on Azure AI Foundry, bringing those advanced specialized agents we talked about. But these aren't just agents summarizing research. These are agents capable of conducting research.
Conducting research. How?
They describe science agents that can cooperate in a continuous, iterative cycle. They can generate hypotheses proposing potential new candidate molecules or materials. Then they orchestrate complex simulations using high-performance computing, HPC, in Azure to predict the properties of those candidates. And finally, they learn from the simulation results to refine their hypotheses and propose better candidates in the next cycle.
An AI-driven research loop. Did they show this?
Yes. John Link gave a really impressive demo. He showed himself leading a team of agents within Microsoft Discovery to tackle a real-world problem, finding new immersion coolants for data centers.
Coolants. Why is that important?
Data centers generate immense heat, and traditional cooling methods are energy-intensive. Immersion cooling, literally submerging servers in a non-conductive fluid, is much more efficient. But many existing coolants use PFAS chemicals, often called forever chemicals, which have serious environmental concerns. So the goal was to find effective PFAS-free coolants.
Okay, a challenging material science problem. How did the agents help?
He showed three main steps. First, reasoning over knowledge. He asked the platform about existing coolants and their properties. The agents used that knowledge graph, reasoning over public and internal scientific data, to provide a deep summary and a comprehensive report, complete with citations.
Step 1. Understand the current landscape.
Right. Step 2. Generating hypotheses and a plan. Based on that research, he asked the agents to formulate a plan to discover a new coolant with specific target properties, like a certain boiling point and dielectric constant needed for data center use.
Did he have to code the plan?
No. The agents automatically built the proposed experimental workflow. It involved integrating various tools, generative chemistry models to propose millions of potential candidate molecules, other AI models to rapidly screen those candidates based on predicted properties, and finally, using large-scale HPC simulations in Azure for detailed validation of the most promising ones. And importantly, he could review and adjust the plan the agents proposed.
So the agents create the research plan, then step 3.
Running the experiments. He clicked Execute, and Microsoft Discovery took over. It orchestrated the entire complex workflow, automatically choosing and managing the necessary HPC resources in Azure he mentioned. It will even integrate quantum computing resources in the future. The agents worked in real time, driving the massive computations needed for the simulations.
And the result?
He showed how this process dramatically compresses the timeline. What might take months or even years of traditional lab work and manual simulation setup can be reduced to potentially days or hours to get a short list of promising candidates.
Did they find one?
They did. He showed the final results, a set of candidate molecules identified by the agents as promising PFAS-free coolants. Analyzing the predicted properties, they looked good.
And the proof?
This was the coolest part. He shared that the platform had synthesized one particularly promising candidate. Then he showed a video from their actual lab, a high-end gaming PC running the demanding game Forza, completely submerged and running stably in the newly discovered coolant with no fans needed at all.
Wow, seeing it work in reality.
He rightly called it very, very cool. They had used this AI-driven scientific discovery process to find a viable candidate for an immersion coolant that doesn't rely on those problematic forever chemicals.
That's incredible, and you can imagine applying this across so many fields.
Absolutely. Therapeutics, drug discovery, semiconductor design, creating entirely new sustainable materials, as they put it, with tools like Microsoft Discovery. The next great breakthrough is yours to discover.
Okay, let's try and wrap this all up. We've gone through the entire tech stack, seeing how each layer contributes to this vision of an open agentic web.
Yeah, it's quite a comprehensive picture, starting with GitHub and Copilot, creating that open ecosystem for software development, empowering individual developers.
Then moving up to Microsoft 365 Copilot, Teams, and Copilot Studio, bringing agents directly into everyday work roles and business processes.
Underneath that, Azure AI Foundry acting as the core agent factory, the platform for building, training, deploying, and managing virtually any AI application or agent, leveraging any kind of data.
All running on world-class infrastructure, optimized specifically for AI workloads, offering incredible scale and performance.
And crucially, as you said earlier, All of this is built on robust, enterprise-grade Rails, consistent systems for management, for identity using Entra ID that now extends to agents, and for security leveraging Purview and Defender across the stack.
So the ultimate message behind presenting this whole integrated platform.
It really came down to creating opportunity, providing the tools and the platform to fuel your ambition, the ambition of developers and organizations everywhere to build amazing things.
They shared some quick, inspiring examples of that already happening.
They did. Really touching stories. A father in Spain using Foundry to dramatically accelerate the diagnosis process for his son's rare disease. A startup in South America building an app using these tools to gamify wellness and improve health outcomes. An airline in Japan using one of those small file language models running locally on devices at 30,000 feet to help flight attendants complete their reports more efficiently.
Real-world impact, big and small.
Exactly.
Right.
Satya drove this point home in his closing remarks. He emphasized that, in his view, the big winners of this AI transformation are going to be people like yourselves who are going to build these applications, not just people who create platforms like us.
So the value creation needs to be broad.
Yes, he said the winners need to be across every sector of the economy in every part of the world. It reinforced that core mission they stated at the beginning. It's never been about the technology. It's about what people can do with it.
And they ended with one final, really powerful example of that human impact.
Yes, the World Bank study. They had conducted research in Nigeria and found that students using Copilot experienced what the study called the best, most effective educational intervention involving tech that they had ever encountered. Really significant learning gains.
Wow, that's huge for education.
And based on that success, the program is now expanding to Peru. But this time, focusing specifically on empowering teachers, giving them AI tools like Copilot to help enhance their lesson plans, personalize learning, ultimately improve student outcomes, and also help the teachers themselves grow in their careers. A fantastic example of AI empowering people.
Okay, what a journey through that material. As we wrap up this deep dive, it's really striking to consider the potential trajectory here. We've seen these AI agents rapidly becoming more capable, understanding complex goals, planning, taking autonomous actions, even collaborating with each other.
And they're being integrated everywhere, aren't they? Deep into developer workflows with GitHub Copilot agent mode, into everyday knowledge work with M365 Copilot, enabling entirely new enterprise processes via Copilot Studio and Foundry, and now even accelerating fundamental scientific discovery with platforms like Microsoft Discovery.
Powered by infrastructure that offers unprecedented scale and efficiency, running these sophisticated models across the global cloud, increasingly out to the edge, and now even locally on your own PC with things like Windows AI Foundry and local models like Silica.
And connected by emerging standards like MCP, allowing these agents to securely access diverse data sources and services, whether they're cloud APIs, enterprise systems, or even desktop applications like Figma.
So the final thought for you, our listener, is this. As we enter this new era of the open agentic web with these increasingly powerful tools and platforms becoming available, how will you harness these emerging capabilities?
How might you use them to transform your own work, to solve challenging problems in your community or your industry, or perhaps to build that next groundbreaking innovation, something that simply wasn't possible before?
The opportunity, as Kevin Scott suggested, feels truly limitless, driven by collective imagination.